This lesson, we're going to talk about solving radical equations. Radical equations, again, will be the same method of solving absolute value or rational equations. Trying to get rid of the sign, so we will bring it into linear or quadratic to finish solving that equations. So when you're looking at the first problems, you see here, one side is all square roots, and we learned square roots and square is inverse, where it will cancel out each other, right? So if you have only square roots one side, you can use square to get rid of that square. And you do know that whatever you do one side, you need to do the same thing on the other side. That will cancel out square roots. What's remaining then? We have 20 minus 8x equals 2x squared. Without the square roots, look like this is going to be quadratic again, highest exponent being square, right? So square, we wanted to make a standard form equals to 0 and make leading coefficient positive, right? Positive 1. So it means we wanted to move everything to the right side, right? So if I move everything to the right side, then I will have x squared plus 8x minus 20 equals to 0. Make it standard form. And then let's see if we can factor. I know this is going to be factorable because x different sign. X times x is x squared, different sign. One is positive, one is negative. And if you have a 10 times 2, that makes it 20. 10 minus 2 will be 8, right? So that's how we're going to factor. This means your x is going to be negative 10 and positive 2, right? Negative 10, positive 2 when you solve for each linear, right? And this is another one you need to check the solutions. So radical equation, and this is full check is required. So there is two equation we went over that need to check your solution. One is radical, one is rational. Rational one that we learned that you don't need to do full check. You can just make sure your solution is not one of the restrictions, right? Radical equation, you need to do full checking. So when you check these solutions, you're going to replace x with each value and see which one works and which one do not work. So then 20 minus 8 times negative 10 should gives you negative 10 squared. That gives you 20, adding will give you 100, right? So it will be 100. Is this equals to negative 10? Oh, that wasn't square, right? Square was something that I square each side. So it will be just 10. Negative 10. And which square root of 100 is 10, not negative 10. So that's something you cannot have. But if you replace x with 2, let's say if we get 8 times 2 should be 2. Let's say if we get that. This is going to be 20 minus 16, so it will be 4. Is that equals to 2? Yep. So only solution I can keep is this one, 2. Right? And you can see obviously why I said that you need to check your solution. You must check the solution in radical equations because usually one works and one don't work. Sometimes both work, sometimes both not work. So you need to make sure you need to check the solutions. Let's try the next one. So this one, it's already only square root one side. So I will square both sides of equations. Then I will get x plus 10 on the left side. Right side, I will get x minus 2 square, where you need to do FOIL. Make sure you don't distribute square, right? You cannot distribute when you have addition subtractions on a base. So when you do FOIL, you get x squared minus 4x plus 4 is what you get. Again, we're looking at quadratic, so we wanted to move everything to the right side and make it standard form equals to 0. So you will subtract x and subtract 10. You get x squared minus 5x minus 6 equals to 0. When you factor, you get x minus 6, x plus 1 equals 0. So here you have two solutions again. Let's see. We can check, and when it's 6, it should be 6 minus 2, which is 4. Let's see if we get 4. That's square root of 16. Is this 4? Yep. So that's something we can keep. What about negative 1? Can we keep negative 1? Negative 1 plus 10. And this is negative 1 minus 2. That gives you square root of 9, which is 3. It's not negative 3. So that's something we cannot keep. So your solution x should be only 6. Because negative 1 didn't work, right? What about C? C, I see the square root, so we wanted to square to get rid of square roots, but I cannot square when you have anything else that's attached, right? I only wanted to have square roots with square, so that will cancel out each other without doing foiling. So let's get rid of this by subtracting x. Then you get negative square root of x plus 11 equals 2. 1 minus x. When you multiply by 1 or divide by negative 1 or multiply by negative 1, you get positive, and this becomes x minus 1. So changing the signs by multiplying or dividing by negative 1. Let me write it as multiply by negative 1. Right? And then now we can square it. Square this side, square this side. Then I get x plus 4 on the left side. Right side should be foiling again. So x squared minus 2x plus 1. Subtract x, subtract 4. To make it standard form equals to 0. I get x squared minus 3x minus 3 equals to 0. Okay, I think I missed number somewhere. So this one was 11, right? So this should be 11, not 4. So this is all 11. You're subtracting 11. You're subtracting 11. So this number should be not 3. It will be 10. And when we factor it, we get x minus 5. X plus 2. where x should be 5 and negative 2. Again, we need to check. 5 minus square root of 5 plus 11 should be 1. That's 5 minus 16, so 4, that's 1. Yep, that works out. What about negative 2? Negative 2 minus square root of negative 2 plus 11. That should be negative 2. That will be 9, so it will be negative 3. Is this equals to negative 2? Nope. This is equals to negative 5. It's not equals to 1. So that's something I cannot use. So x should be only 5. So that's how you're going to solve radical equations. Remember radical, trying to get rid of radical to make it linear or quadratic, right? Trying to get rid of square roots, using square to make it quadratic. We already know how to solve quadratic, right? And check the solutions. That's all to it, to solving radical equations.